So let's do a little review. What are the 4 phylums of plants? Do you remember? You have kingdom and then you have 4 phylums. If you said ferns, mosses, angiosperms, and gymnosperms, you're absolutely correct. And you're definitely going to see that question again. So now let's focus on our angiosperms. Angiosperms means what? Flowering plant. And the angiosperms, the flowering plants, are broken down into 2 classes. What are those 2 classes? Hopefully you remember. Monocot and Dicot. So we planted some little seedlings, and we'll see when they come up if they're monocots or dicots. That means that when they first germinate and sprout out of the seed coat and just to break the soil, they either have 1 leaflet or 2 leaflets. So that's a way you can visually tell if it's a monocot or a dicot, but there's a lot more important things about these that makes them different. Now you should have downloaded a worksheet. If you didn't, just take notes, but the worksheet should make it a little bit easier for you to take notes on this. So let's put monocot over here and dicot over here. All right, so first let's talk about the roots. How are the roots different? So in the monocot, your roots are fibrous. That means they branch out. In the dicot, your root tends to be a taproot, which means that it's going to grow more like this, okay? So those are the differences in the roots, and you're going to find out why some of these differences are important. Number 2, we're going to talk about wood. Let's talk about wood. So that's the roots. Wood. So monocots do not produce wood, and dicots do produce wood. So as you can imagine, most of your trees you can automatically say are dicots because they produce wood. Now a palm tree, if you see down on the coast, down around Florida, a palm tree is not actually a dicot. A palm tree is a monocot, and it doesn't actually produce wood. So that's something sort of interesting. If you can imagine, when you go to the lumber yard, some of y'all who have built fences and things like that, you don't ever ask for palm tree wood. You ask for palm tree lumber because it doesn't make wood. Monocot, leaf veins. So the leaf veins are parallel. So we're talking about if that's the leaf blade, okay, and that's the petiole, we're talking about the leaf veins run like that. So go ahead and just start thinking about some things that look kind of like that you may have seen before. And the leaf veins in the dicot are branched. So you have a leaf blade, petiole, and your leaves are going to go, your veins are going to go somewhat like that. Okay? So those are the leaf veins. Vascular system. In the monocot, when you do a little cross section and you look at the vascular system, what is the vascular system made of? 2 things. Xy to the sky and flow to the ground. Flow down the phloem. So we got the xylem and the phloem. So the vascular system, if you look at a cross section of a monocot, there's no real, this is vascular system. There's just no real pattern to it. It's just wherever. Okay. If you look at a cross section of a dicot, the vascular system is actually in bundles that makes rings. Now, this is going to be important because I'm going to show you a slide that has, and then you might have another ring of that. So I'm going to show you a slide and ask you if it's a monocot or a dicot by looking at the vascular system. So if you have rings of vascular system, xylem and phloem, it's a dicot, and if you have no particular arrangement, it's a monocot. All right, I'm going to erase this so I've got a little more room. Endosperm. So what is endosperm? So an endosperm, and you may remember me saying that term when we were planting our little seeds. So an endosperm is actually the food that the little cotyledon, the little baby plant, eats before he's born, okay? It's the food for the seed, for the embryonic plant. It's actually an embryonic plant before it germinates. Then it becomes a cotyledon, which is either a monocot or a dicot cotyledon. So it's the food that the embryonic plant eats. So in a monocot, the endosperm is, I don't want to say this, it sounds complicated, but it's not. It's separate from the embryo, but it's inside the seed coat. But not part, let's just say not part of the cotyledon. So we know cotyledon's a baby plant. All right. So in the dicot, it's actually in part of the cotyledon. So it's actually part of the baby plant itself. So think about, like, you know, when you have a good bit of fat on you, your body actually uses that fat for energy. So it's kind of the same thing. So the dicot, is, think about the little embryonic plant, it's just a little fat plant, and it uses its fat to for energy, and that fat is actually the endosperm. So the dicot, the endosperm, is part of the cotyledon. All right. Last thing, let's talk about examples. So hopefully you are thinking about some leaves that have parallel veins. One example of monocot is going to be grains. So if you think about corn, doesn't that sound familiar? If you go to the grocery store and you look at, you look at the corn and think about the leaves on the corn plant. If you've ever seen it grow, you can actually see the parallel veins. An example of dicots is legumes. Now, where have you seen legumes before? Where have we talked about legumes before? Hopefully you recognize legumes, as legumes is the type of plant that rhizobium attacks it infects the roots and makes the nodes, but it's actually a good infestation. Remember, rhizobium is a good bacteria. So when it makes its little nodes and sets up house in those nodes in legumes, okay, then it changes unusable nitrogen into usable nitrogen for the plant. They cooperate. So that's where you should have seen legumes before. Can you think of what a legume is? You cook with legumes. So a legume would be like a green bean or a soybean or a peanut. It's anything that creates a pod. So that's how you can remember a legume is something that creates a pod, like a sugar snap peas or sugar snap beans. All right, so that's monocot and dicot. Now, why are some of these things important? Do you remember when we were talking about auxins, and we said that auxins can be used actually against plants in the form of a herbicide called 2,4-D. So auxins causes, if you put an overdose of auxins, it causes the plant to basically overgrow, just grow so fast it can't keep up, and it overgrows itself to death and dies. So even though D stands for something totally different, it doesn't really stand for dicot, this is a good way for you to remember 2,4-D affects dicots, okay? So that's why it's important to know, do you have monocots or do you have dicots before you put something down, a pesticide that may kill one or the other. So you can go into a wheat field or corn field or even grass. You can go into all these places and you can spray your 2,4-D, and it's going to attack all your little dicot weeds. Not every single dicot is a legume. This is just an example, but it'll attack your little tiny trees that are wanting to come up, anything like that. So 2,4-D is actually used against dicots, and it's going to leave your monocots alone. So that's just one example why it's important to understand the difference. All right, I'll see you next video.